Alright, for those of you guys watching this video again, because thankfully everybody is here, we just went over the examples for 4, 5, and 6 geometric series tests. We're moving on to divergence tests.
I do have a question.
I want to answer Gabby's question, but I won't unless we're actually respecting her and listening to what it might be. Okay, Gabby, go.
Wait, so is this basically finding a limit with...
No.
This is... No?
Yes or no? Finding a limit, yes, because these are infinite, and so infinite we can't plug in infinity, so in a sense we are approaching. But what are we taking the limit of? We're taking the limit of the partial sums. Does that make sense? And so for all of these in the geometric series, technically we could have used the old-fashioned pre-cal formula that said S sub n, here we go, that said S sub n. I swear I wrote the old-fashioned pre-cal formula somewhere. Where did I write it?
That was it.
Oh, right here. The old-fashioned pre-cal formula says, hey, for geometric series, I can find the nth partial sum using this really nifty formula. So technically, we could have plugged into this big, long formula every single time, but what would happen every single time is if r is greater than or equal to 1 or less than or equal to negative 1, this will always go to infinity, so then forget it, this would always diverge. And then whenever r is in between negative 1 and 1, and we plugged in, this would go to 0, and I go ahead and end up with this statement. So what we're doing is shortcutting the process of needing to take the limit as n goes to infinity of the partial sum of geometric series. For every other series, can I say this? For every other series and test that we're going to see beyond geometric, there is no established nth partial sum formula that we can take a limit of, and hence the dilemma. This is the easiest type as far as solving and why we can solve for the convergent sum, because there is an nth partial sum formula that we can use. Okay. So, speaking of other tests, this is the second one for section 9.2. Section 9.2 OT, other textbook, online class folder, handouts, the scanned copies of the pages from this for Jason, the 10th edition Larson textbook that you will be using for these homeworks. Okay. Did I miss a question?
I think I'll wait. You'll probably...
Sounds good. This is endeavor number 14, but hold on to it in case I don't. Endeavor number 14. Divergence test, otherwise known as the nth term test. Divergence test, otherwise known as the nth term test. Ooh, we can look at the nth term? Yes! And sometimes it tells us everything, and sometimes it tells us nothing. And it's the danger. It's the very dangerous test. A very nice test, but a very dangerous test. Very nice test. My prediction was right. They are both 19.
Okay.
I snapped this morning because I got new creamers and I didn't have time to go to the store with like big ones, and I was like, I bet they'll both be gone.
Like good or bad?
I'm like, well,
Well, I can promise you it was not me.
good for the kids and the taste of their coffee. Bad for me and the need to buy more creamer again. Okay.
If you don't buy
After
any,
we finish the CalcBC sweatshirts, then the coffee can will come back out for donuts.
if you don't buy any, I will complain.
You don't show up, Corey.
I never showed up.
But he does come after school,
Yep.
especially when a test is coming. The limit as k goes to infinity of a sub k. If you would like it better, you can say the limit as n goes to infinity of a sub n. I don't care. It's technically how I think about it. You don't have to use the a's if you don't want to. If the limit of the nth term, not the sums, the term, if the limit of the nth term does not equal 0, I can say for certain that the series diverges, the infinite series. I know I didn't put the bounds. I was too lazy, and I stole this from someone else who did not put the bounds, so therefore there you go. The infinite series will diverge. If the nth term does not approach 0, the series will diverge. Done. But the dilemma and the danger is many of you, when you're told a fact, say, oh, then the opposite is also true. Can I think of an example of that?
Right.
If it's not right, then it's left.
If it's not right, then it's left.
Right across from.
If it's not wrong, then it's right. If it's not right, then it's wrong. That's a
It
hard
could be
one.
straight.
If it's not straight, then it's crooked. If it's not crooked, then it's straight.
Would you rather go right or go left?
Could. I mean, you can go forward, or you can.
If you're not going forwards, then you're going backwards. Wait. You could be stopped though.
Yeah, that too. You could go.
But don't, wait, but wouldn't a lot of people in their natural logical sense say, well, if it's not this, then it's that? Right?
Yeah.
So many judgment calls.
That was apologetics. Oh, wait.
There's a lot of good applications to this type of thinking, but is it sometimes true?
Sometimes,
Is it sometimes true?
very much so.
Okay. But is it sometimes a gray area, or even false?
Yes.
Yeah. Like my example of if you're not going forwards, you're going backwards.
Yeah, stop.
Well, it could just be stopped, right?
Yeah.
So there could be exceptions. It could be mostly the opposite, but then not always. Okay, we're not going to go into depth into all of that, even though we could have tons of fun with going into depth with that. And a lot of logical fallacies that are present everywhere, even in supposedly really smart people that try to give commentaries on what's going on in our world and politics and all sorts of things. But coming back, the Bible's more important than politics. But just saying, so is loving Jesus, so don't let your testimony be ever ruined from something as silly as politics. Coming back, divergence test. On either side, whatever way you lean. Coming back. Question. If the limit of the nth term does not equal 0, the series diverges. Well, fine. If the limit of the nth term does equal 0, then the series, you don't know anything. AKA you know nothing. AKA you can't see anything. AKA the test fails. So I want you guys to write in here. If the limit, the nth term, what am I talking about? The nth term, n is going to infinity. So the nth term, as you approach infinity, if the nth term is approaching 0, this test fails. You know nothing. But one of the most common dangers is a lot of calculus kids, even after doing this for weeks and weeks and taking multiple tests and getting to the AP, still make the mistake of, oh yay, it converges. You know nothing. 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 The test, the nth term test, can only show divergence, which is why it's called a divergence test, because it can only test for divergence. Geometric series we can test if it's a geometric series for convergence and divergence. We can tell both. If r is greater than 1 and greater than or equal to 1, or less than or equal to -1, divergence. And if it's not diverging, yay, it's converging. But this test says if the limit of the nth term is not 0, then it diverges, it meaning the infinite series. But if the limit does equal 0, we know nothing. True? Is there an example somewhere else in calculus last year where there is a test that only sometimes works?
Second derivative test?
The second derivative test for relative extrema. Wait, help me out, because you guys always miss this when I put it on the quiz anyway. I was part of it.
I got it.
If
I'm always very.
F exists. Okay, if F exists, there's more than that. If F exists
If it equals.
at
Interval.
x equals c,
Within A to B.
no.
Wait, no, if the.
Relative extrema. Relative extrema can only occur when?
It's continuous.
Oh, it occurs.
The second derivative again.
There's critical points, there's end.
Critical points.
Yeah.
Good
Not
point.
endpoints, that's absolute extrema. Relative extrema can only occur at critical points. So first of all, at x equals c, a critical number of f. If f double prime of c, you're testing critical numbers, you have to set the first derivative equal to 0 or dne. If the second derivative at c is positive, what do we know the function has? A relative min. If at a critical number the concavity is positive, or the second derivative is positive, the concavity is up, I have a relative min. If the second derivative at c, at the critical number of f, is negative, what do I know must be there?
Max.
A max. But if the second derivative is 0 or dne, what do I not know? I don't know anything. The test fails. Go back to the first derivative test. Thank you. Test increasing, decreasing. Give me an example of a function that would fail and yet still have a relative min or max.
Piecewise.
Sure, give me an example. Easy one. It's on your basic graphs card.
X cubed. X to the fifth.
Tangent inverse.
Tangent inverse. Tangent.
They don't tangent does have a max or min.
Sine, cosine.
That's a value of x. Killing me.
Parabola.
X
What's the second derivative? The first derivative doesn't even exist. The second derivative doesn't exist. Okay, so the test fails, and you would have to look at the decreasing, increasing nature of the graph, the first derivative, to even figure out it's a min. True?
Yes.
Thank you. This test sometimes fails as well. Really quickly, when you're given an infinite series, the very first thing I almost always, sometimes it's hard, I almost always want you to do when given an infinite series, from here until the end of the year and beyond, whenever you're given an infinite series, first thing to do is take the limit as n goes to infinity of a sub n.
Okay.
But you must get stuck into your head the three different possibilities.
Ooh, this is nice.
The limit does not exist. Well, it's not zero, diverges.
Let's go.
Go again. The limit does not exist. Well, it's not zero, diverges from the divergence test, right? It can be infinity, negative infinity, it could be DNE because it oscillates. If the limit does not exist, divergent. If the limit exists and is anything besides zero, which could still be infinity, negative infinity, but also all non-zero constants, divergent. If the limit exists and is zero, no, nothing, try another test. Okay, here we go. Ready? Set? Question. I know you're not going to like this, but that's okay. Number one, is it a geometric series? Why not? Why not?
Because it's not
Why not? Isn't the first term 1 and the second term 4 and the third term 9? Question, can I multiply by a common ratio?
No.
That's why not. Thank you. So, since it's not a geometric series test, what can I say? Since the limit as n goes to infinity of n squared equals what?
Infinity.
Whoa.
Which does not equal 0, the series diverges by the n term test. We have another test, so now we need to distinguish which test we're using because now we have two. Number 2, geometric, yes or no?
No.
Why not?
Because
why?
I can't think of that. If you plug in numbers,
Wait,
the
what
R
do we plug
doesn't
in for
exist.
x?
There's no ratio, it's too confusing. Her ratio.
Well,
Is it Horatio?
he did. But what's going on with the problem?
There's still
What?
X. It's not a pure
I'm
number.
asking you a question.
It's not a pure number.
ln of 1 equals? 0. Okay, number over 0 is?
Is there
Oh,
a...
that's a problem. But let's keep looking. Even if we were to keep going, if I have x squared all over ln of 2, if I have x cubed all over ln of 3,
Who's it? X.
I don't know.
It approaches infinity.
Somebody.
I'm so confused.
The denominator continually gets bigger.
Change the bigger.
X, assume x is a constant,
Thing is smaller.
because we're not changing x at all. X is not varying, so we assume it's a constant. So what's going on?
Probably 0.
Yeah, definitely.
No, it's infinity now, because if you derive
But
that,
the constant is being squared and then cubed and then continuing on and on and on, right?
but it's not.
Isn't a number over 0 like, so when you think of vertical asymptotes, vertical asymptotes are just positive or negative infinity? So doesn't this support positive infinity?
Just top one first.
Yeah, that's true.
Bottom ones or top ones?
Top one.
Top ones. Because the ln is increasing, but the ln is increasing slowly. You're raising your powers on top of it.
That's
You're raising
okay.
your powers. Think of 2 to the n. Is 2 to the n stronger or ln of n? Yeah, there you go. So therefore, I could say since, and technically kiddos, I think this is a bad problem. They would start it at 2, to be totally honest.
You could derive it and it becomes n times x.
Coming back, can you guys change it to n equals 2? Okay. And what Noah is saying is that you could think of L'Hopital's, right? Because you can make that c to the n and then ln of n, and then you can go ahead and when you take the derivative, you would end up with ultimately infinity over, well, first infinity over infinity, but then when you derive, yes, the top will win. Remember, L'Hopital's is not, we're taking limits, we can do L'Hopital's. Since the limit as n goes to infinity of x to the n all over ln of n equals infinity, what can I say?
The series
Which is not 0. The series diverges
by the n times x.
by the nth term test. Can we just say nth term?
Why do you call it nth term?
Where are you allowed to?
No, I think she wants to write everything, but it's just a problem with
What is the divergence test?
Yeah, but what's written in parentheses? Got it.
I don't see parentheses.
Oh, look at the end of it.
Oh, that,
There you
oh.
Number 3, is it geometric? Oh, it is? Okay, cool. Because plugging in 1, we get 2 over 1, which is 2. Plugging in 2, we get 3 over 2.
Yeah.
Plugging in 3, we get
4, 2. Oh, no.
plugging in 3, we get 4/3. Plugging in 4, we get 5/4. Okay, what are you multiplying by?
Nothing.
Nothing constant. So therefore, is it geometric?
No.
No. Since the limit as n goes to infinity of n plus 1 over n equals 1, which is not
equals
0, what does the series do?
Diverges by the nth term test.
That's
Now.
divergence.
Kiddos, here's something and here's something well.
Yes.
Ready?
Yes.
I'm having you guys check geometric series first, just to have you keep practicing the geometric series test. But just a moment ago, I said whenever you see an infinite sum, the first thing I want you to do from here on out,
Take the root.
take the limit and see if it's 0, no nothing, or if it's a non-zero, sweet, diverges, stop. Okay, so technically what I'm having you do with the geometric series is just practicing the test that we've already learned. The series diverges by the nth term. Why? Well, 1's not 0. John?
So if it's not geometric, it diverges.
Geometric series is a completely different test
Yeah, follow the trend.
than the nth term test. But let's go ahead and take what John said. Let's go back to those ones that we did do with geometric
Wait, yeah,
series.
that's true though.
Question. Could we see that this converges by the nth term test? What's the limit as n goes to infinity of this guy? Which means? We know nothing. Okay, well we knew it
We're done.
wasn't guaranteed to diverge. This one, what's the limit as n goes to infinity? This one just oscillates, that's 0, we know nothing, right? Number 3, how about this one? Nth term test. 0, we know nothing. How about this one? Nth term test.
One. 5.
Infinity over
It's
there?
5.
3.
Negative 1/4 raised to the infinity is 0. 5 times 0 is 0. We know nothing. How about this one?
There's one big, nothing. 1 to the infinity is an indeterminate form, L'Hopital's.
So, it doesn't seem to be 0,
The hospital is.
right? It doesn't seem to be 0. We could go ahead and try to do L'Hopital's. How would we do L'Hopital's?
You don't.
The hospital is.
Wouldn't be very fun.
You have to take ln of the side, drop the n down.
Let's just say geometric series is the easiest way to show it diverges, but maybe it makes a little sense as to why it diverges if the limit is not exactly, just be careful. It technically is indeterminate, so we'd have to figure out what's going on. The nice thing is, as soon as you start expanding the sum, it's very apparent. I would not still use the nth term test on this one. How about on this one? Limit as n goes to infinity.
It's same thing.
Same
Negative
thing.
1 to the infinity.
Same thing.
L'Hopital's.
However, hold on. I didn't give you any good ones? I didn't give, well, I gave you some good ones. How about this one?
Dang it.
What if I was to, be nice. What if I was to give you the sum as k goes from 1 to infinity of, haha. You're welcome.
That's still a number.
Wait,
It is still a number.
that's a number.
E over 2 is
Oh, man.
A number
the
to
common
the
ratio.
0!
No, it's more than 1.
I'm just gonna.
I have broken
Is it more than 1 or less than 1? What is it? What am I talking about?
E over 2. It's more than 1.
No, it isn't. 2.6.
Also, it's
Yeah,
1.359.
Is this?
No,
That's
one
one.
point something.
0.359.
I'm so confused.
E is 2.7.
What's the limit? Yeah, exactly.
Thanks, Laura.
2.71828.
Also, the one at the top one.
I don't think mine E.
Or am I just saying random stuff?
Gabby, can prove them wrong. I'm sorry, I can't prove your logical fallacies.
Do they need the geometric series to do this one? No. Why is E stronger than 2? Because it's 2.71828, so it's a bigger number. Coming back though.
Wait. Why do we call it E?
Coming back though. Could we have also proven this with a geometric series test?
Yes.
How could we have done that? Since R is equal to?
E over 2.
E over 2, which is greater than 1. We don't even have to say what it is. Whatever, it's greater than 1. Since it's greater than 1, what can we say?
Series divergence.
The series diverges by,
Geometric.
I'm not sure if this answers your question, but at least it illustrates the answer. That help?
No, wait, isn't that just still proof what he says?
Yes, so sometimes more than one test applies.
Oh.
Does that make
I
sense?
thought he was.
So I was showing you guys all these ones saying, could I have done the nth term test to them? Yes, but I wouldn't have gotten very far. So the nth term test didn't really help. But this one could have been geometric series, and if I had done the nth term test, it actually would have, ooh, hey, nice, go team. It would have actually proven it maybe a little bit faster. Lucy.
When we were finding the R, like how we did for the second one, is that when it's a geometric series?
Yes.
Okay.
Yes,
Other than that,
it's the common ratio because there is a constant that's being multiplied over and over and over again.
So should we, when we have problems like that, should we first check whether it's geometric or not and then take the limit if it's not?
Well, it's up to you guys. I mean, on these ones, we can take the limit pretty fast and realize it's 0. We'll forget that. Let's take,
Yeah.
and then, like in this homework, you know it's either one or the other. So it's not like you have all 9 tests yet and you have all these other crazy ones.
Yeah.
So it's not a bad idea to take the nth term test because it's fast. But as soon as you see it's 0, say, okay, fine, it must be geometric. Let me see what I can do.
And then find like the R. Okay.
So you could always, like for these ones, you could always expand it first and see if there's a common ratio. But I would say take the limit first, because on this one, before you ever even expand it, well, okay, this one was hard. I was trying to make sure you guys knew what E was. But in this one, when you expanded it, it probably wouldn't help much. If it was something like 5 over 4, be like, oh, hey, cool, limit, that's going to be 5 over 4, something greater than 1 raised to the infinity is going to be infinity. You can stop without even having to expand it all and figure out what the R is, et cetera, et cetera. Okay, although the logic is pretty similar as to why it works. Kiddos, we're on number 4, yeah?
Yes, ma'am.
What do we got?
To the end.
What's the limit to the end? What can I say? Series diverges. How about this one? Since. Who wins? How do we know? Is there a special series in that endeavor card that says factorial stronger?
Yep.
Good. Series diverges, right? By the nth term test. How about number 6?
1/2.
Ooh, 1/2? You guys agree?
How did you know it?
These are tied.
Whoa. Oh, that's why, wait.
It's the bottom.
Hey kiddos,
I'm ready for the story.
what's going on right above? That Lucy's trying to help us out with.
0. Because at the bottom one.
Pause.
We don't have
Who wins on this guy? Bottom wins, which means the limit is?
0.
Which means you are going to answer when it comes in homework to?
0.
You don't know, no.
I got it. You got nothing.
Can I
Yeah, you did. I didn't get it.
It's geometric, right? No. I'm there you go.
You should make notes on it again.
I didn't realize he was on the bottom.
Oh, do you need sound?
We were so
Oh, the other